All right, I'm back. Had some technical difficulties and then I'm back. So when we're talking about determining the atomic mass of an isotope, we know that it is neutrons plus the protons. We cannot change the number of protons because if we change the number of protons, then that means we are changing the actual element itself. So we cannot change those. But the neutrons, yeah, the neutrons can change. We can have, we can have 6 protons, 6 neutrons, or we can have 7 neutrons, 8 neutrons, 27 neutrons. But the number of protons cannot change and it still be the same element. So let's look at this next part. We have the number of neutrons, number of protons, number of electrons, and therefore we have to name the isotope. Now, realistically, these electrons part, they don't really matter right now. I mean, they matter, but not really. When you're trying to name the isotope, you really need to look at the number of protons. So with the number of protons, that will tell us, all right, we already know, it'll tell us the element that we're working with. So if I have 2 protons, I already know that that is helium. If I have 3, I'm dealing with lithium. And you can do, in practicing this on your own, you can do one at a time, or, I just fill in the whole chart while I'm looking at the periodic table. 5 is boron, 7 is nitrogen, 8 is oxygen, and 10 is neon. I actually don't have the periodic table in front of me. When y'all ask if you have to memorize the periodic table, no, you don't have to memorize it, but there's some that you'll just need to know just because you use them a lot. So we have helium, and we have our number of protons and our number of neutrons. We know that neutrons plus protons will tell us the mass that goes with that to make it the isotope. So all I have to do is 1 plus 2, I have helium 3. 3 plus 3, I got lithium 6. And you've heard of lithium. Lithium is when you talk about batteries and stuff. 5 plus 5, we have boron 10. You have 8 plus 7, we got nickel 15. We have oxygen 17 and neon 21. Easy enough. So let's look at this last part, which is just more practice with this. Pause the video and figure these out on your own. It's a good place to pause. I'm giving you time to pause. And now I'm back in case you did not pause it. But let's do the same thing. We got our number of protons, and that tells us the name of the element, first of all. So if I have 12, I'm working with magnesium. 14 is silicone. I have 14 again, silicone. 16 is sulfur, pretty sure. 20 is argon. Oops. And 19 is potassium, which potassium, the symbol is a K. So now let's look at our number of neutrons plus our protons. So we got 14 plus 12, I have magnesium 26, silicone 19, oops, 19. This one's different, so it's still, but it's, we can see it's the same element, but they're 2 different isotopes of that element. So silicone 30. And, bonus question, if I'm wanting to know, what's the original one, it'd be 14 and 14. It might be silicone, my bad. Because I did that wrong. That's gonna let me just be wrong. That's not right. That's why I was like, that's not right. It's 29. Just kidding. Yeah, because then the other one would be silicone 28. And with isotopes, this, however, they, sometimes they naturally are just, you might just have a silicone 29. It's just the natural way it is. Anyway, continuing on. Sulfur, we are at 33. Argon, we are at 44. And potassium, 41. And that is our answer. Boom. Smiley face. Oops. And we are done.